So, when you look up at the night sky, what do you actually think space sounds like?
Right.
I mean, do you imagine those laser battles, roaring rockets, or, that majestic score from a sci-fi blockbuster?
Absolutely. But the thing is, the reality of cosmic acoustics is, well, it's a lot quieter.
And yet, somehow, far more musical than Hollywood would have you believe.
To get started, I think we have to tackle the biggest misconception right out of the gate.
Okay, what is it?
Space is, scientifically speaking, silent. Completely silent. Sound as we know it. These mechanical waves, they just can't travel through a vacuum.
Okay, let's break that down. So on Earth, sound waves need something to travel through, right? A medium.
Exactly. Like the molecules in our air or in water.
Sound works by particles literally bumping into each other.
But in the vacuum of space, the matter is just so spread out. The particles are too far apart.
There's nothing to bump into.
Nothing at all. This is precisely why astronauts have to use radio equipment to communicate.
Because radio waves are different, they're electromagnetic.
And they don't need any medium. They travel just fine through the void.
Which means every single dramatic explosion or screaming spaceship engine you've ever heard in a movie.
Scientifically impossible. In reality, it would be just quiet.
Which brings up a really fascinating question. If space is silent, how do scientists keep releasing these incredible audio clips of planets and stars?
They're doing something called sonification.
Sonification, that's the key.
It's this brilliant process of turning non-audio data things, like electromagnetic radiation, into audible sound waves that our ears can actually hear. It's a translation.
So even though the void is silent, it's not empty. It's buzzing with all this electromagnetic activity.
It absolutely is. Every planet, every star, it all emits unique radio signals, usually from its magnetic field interacting with particles from the sun.
The solar wind.
Exactly. Probes capture these signals, and sonification just converts that electrical data into sound.
So we're not recording sound, we're recording radio waves and then playing them back as if they were music. And the results are, well, they're unique to each planet, right?
Stunningly unique. Take the gas giants, for instance. The Voyager probes showed that Jupiter is known for these intense, chaotic, roaring radio storms.
Roaring storm.
It sounds like massive, violent thunder. And by listening to how those roars change, astronomers can actually learn about Jupiter's powerful magnetic field.
So it's not just a cool sound, it's a genuine analytical tool.
It is. The human ear is incredible at picking up subtle changes in pitch or rhythm that a computer just staring at a graph might miss.
And what about Saturn? Is it similar?
Completely different. Saturn produces these shimmering ethereal tones. People say it sounds like whistling wind or even distant, eerie choral voices.
Wow. And that tells us about the particles around its rings.
Yeah, about their density and structure. It's all data, just in form we can hear.
So that's for magnetic fields.
Yeah.
What about things that are purely visual, like distant stars? How does that work?
In that case, the process is a bit more abstract. It's almost like creating a musical score from a painting.
Okay, so you map the visual information to musical notes.
Precisely. Think about a telescope image. The position of a star, say, higher up in the image, could become a higher pitch.
And I'm guessing brightness becomes volume.
Brightness could be volume, absolutely.
Yeah.
And maybe the size of the star determines how long the note is held.
That's a great analogy. So scanning across a star cluster would sound like a complex, maybe slightly alien orchestra?
It really can. And then you have pulsars.
Ah, the spinning dead star.
Right, neutron stars. They shoot out these beams of radiation, and as they spin, the beams sweep past us, kind of like a lighthouse.
And because they spin so steadily, the signal is incredibly regular.
It creates a perfect rhythmic beat. It's often called the cosmic metronome. It's so reliable, we can use it to map the universe.
And we even heard a comet sing, didn't we? The Rosetta mission and Comet 67P.
We did. It picked up this strange rhythmic clicking sound.
But it wasn't sound right.
No, it was oscillations in the comet's magnetic field as it was being hit by the solar wind. The original frequency was way too low for us to hear.
So they had to speed it up.
Dramatically. The result was this rapid, thumping rhythm, almost like a heartbeat or a drum. It was basically the sound of the comet fighting back against the sun.
That's amazing. It really shows that space is so much more interactive, I guess, than we thought. It almost makes you wonder if people always kind of suspected there was some hidden order out there.
It does raise that question, doesn't it?
Yeah.
Long before we had the technology.
And they did. We can go back centuries to philosophers like Pythagoras. He had this idea called musica universalis.
The harmony of the spheres.
Exactly. The belief was that the planets and stars all moved according to perfect mathematical ratios.
The same ratios that create pleasing musical intervals here on Earth. So the universe was this giant silent instrument.
Playing a divine song that was too pure for human ears. And even though we know that's not literally true, that connection between math, astronomy, and art is still so powerful today.
It is. In music, harmony is all about frequency ratios. In space, orbits follow the precise laws of mechanics. And sometimes, those cosmic movements create real, recognizable musical patterns.
Which brings us to orbital resonance. This is one of my favorite examples.
It's an incredible phenomenon. It's when the orbits of planets in a system relate to each other in simple fractions.
So like one planet might orbit exactly twice for every 3 times another one does.
That's a 2.3 resonance, and it creates a rhythm, a stable, predictable rhythm, because gravity locks them into this cosmic dance.
It's the universe keeping time.
Literally. Composers are now taking these orbital rhythms and turning them into electronic music. The universe is writing its own songs.
So let's bring this back a bit closer to home. What about actual human music played in space? I'm thinking about the astronauts on the International Space Station.
For them, music is hugely important. It's not just entertainment.
It's an emotional connection to Earth.
Exactly. It's vital for their mental health during those long missions. They bring up playlists, of course, but also real instruments.
I've seen pictures of guitars, flutes.
And playing them in microgravity is tricky. If you strum a guitar, the force can push you backward. You have to anchor yourself.
And the instrument itself will just float away if you let go.
Right, so they use straps and Velcro. And on top of all that, they're playing against the constant background noise of the station itself.
It's not quiet up there, is it?
Not at all. There's the constant hum of life support, fans, filters. It never stops.
Yeah.
So they're in this bubble of noise surrounded by perfect silence.
That's quite a contrast. But it turns a cold laboratory into something a little more like home.
It does. And speaking of home and leaving it behind, we have to talk about the most famous cosmic compilation ever made.
The Voyager Golden Record.
Launched in 1977. It was this incredibly ambitious time capsule made of gold-plated copper, designed to last for 1 billion years.
And the idea was that if any intelligent life found it, this would be our greeting card.
It contained so much. Greetings in 55 languages, sounds of Earth like thunder and whale songs, and an amazing selection of music.
An attempt to capture all of human culture on one record.
A pretty good one. You have classical composers like Bach and Mozart, chosen for their mathematical structure.
And traditional music from all over the world, right?
From Peru, Japan, all over. And of course, a bit of modern music.
Chuck Berry's Johnny B. Good.
Yes. The hope was that music, which is based on universal math and physics, could be a language that any intelligent species might be able to understand.
That's such a profound idea, that our art is just floating out there in the dark, weighing.
And speaking of universal things, let's talk about the ultimate sound wave, the echo of creation itself.
You mean the Big Bang?
We could still detect its afterglow.
Yeah.
It's called the cosmic microwave background, the CMB. It's the oldest light in the universe.
And we can use that data to recreate a sound.
We can, because in the first moments after the Big Bang, the universe wasn't empty. It was this hot, incredibly dense soup of plasma.
And that plasma was dense enough to actually carry sound waves.
It was. Massive, slow-moving sound waves were rippling through it everywhere. And those waves are what determined where matter would eventually clump together to form the first stars and galaxies.
So what happened to the sound?
Well, after about 380,000 years, the universe cooled down enough for atoms to form. That made it transparent. And the sound waves, which needed the dense plasma, just stopped.
And they became frozen in place.
Their final vibrations became the light we now see as the cosmic microwave background. Those tiny temperature differences in the CMB maps. They're fossils of those ancient sound waves.
So when scientists convert that data back into sound, what do we hear?
A deep, low-frequency roar. A massive eternal drone. Some people call it the ultimate bass note. It's a direct acoustic link to the birth of the universe.
That's just staggering. It really brings home that idea that music could be the way we finally say hello.
It might be the best way. A simple rhythm or a musical scale follows mathematical rules that are the same everywhere. Some scientists suggest broadcasting melodies based on things like prime numbers or the Fibonacci sequence.
It's proof of intelligent, abstract thought, a sign of hope.
And as we move out into the solar system, to the moon or Mars, our art will evolve with us. Colonists will create new music, new instruments, adapted for those new environments.
What would that even look like or sound like?
Well, imagine massive aeolian harps on Mars, played by the thin desert winds. They could create these haunting, resonant sounds powered by the planet itself.
That's an incredible image. It really suggests that the future of space exploration is going to be just as much about art as it is about
I
science.
think so. The key takeaway is that while space is silent to our ears, it is filled with these mathematical rhythms and electromagnetic patterns. It's a constant, quiet symphony of physics.
So the next time you look up at the stars, remember that the universe isn't roaring like an action movie, but it is playing its own ultimate bass note. And maybe think about how that vastness, that isolation of space, might one day inspire music that sounds completely different from anything we've ever heard on Earth.
A fantastic thought to mull over. Good luck with your studies.